Dear students, in this video we are going to discuss about Zener and Avalanche Breakdown. So in previous video, that is PN junction part 2, we have discussed forward biasing and reverse biasing of PN junction. So how the PN junction will react for the forward biasing and reverse biasing. So during that reverse biasing, we have discussed at a particular voltage, that means at particular voltage the PN junction will breaks down. Okay, so that voltage is called breakdown voltage. That means during the reverse biasing, okay, if the voltage is increased at one particular point, the current will be increased rapidly in the reverse direction. Okay, so that voltage is called breakdown voltage, as already we have discussed. But here there are two types of breakdown voltages are there in the PN junction. So that is named it as Zener Breakdown and Avalanche Breakdown. So let us discuss one by one. First, I would like to explain about the Zener Breakdown voltage. So how the Zener Breakdown voltage occurs. So for example, we are talking about the PN junction and it is reverse biased. PN junction is reverse biased. Okay, so if you are increasing, that means if you are giving the reverse biasing, generally the depletion region will be increased. Okay, the width of the depletion region is increased, so no current will be possible in case of the reverse biasing. But due to the minority charge carriers, very less amount of current will flow through the circuit. That current is named it as reverse saturation current or leakage current. Reverse saturation current or leakage current. Okay, so this current is due to the minority charge carriers. Okay, further, if you are increasing more and more voltage, that time the PN junction will breaks down at a particular voltage. That voltage is called breakdown voltage. So here first let us see how the Zener breakdown voltage takes place. So this Zener breakdown voltage takes place in heavily doped materials. Okay, heavily doped materials. So heavily doped material in the sense, heavily doped PN junction means more and more number of charge carriers will be available. So its depletion region will be thin enough. Okay, so the avalanche breakdown takes place in lightly doped material. Okay, lightly doped material and its depletion region will be high enough. Okay, so let us discuss the Zener breakdown voltage. So this Zener breakdown voltage takes place in heavily doped material. Okay, so when the high electric field is applied, okay, when we are applying the high electric field applied, so the electrons start moving across the junction. Okay, the electron starts moving across the junction. So that time it creates, that it produces the small reverse biased current. Small reverse biased current. Okay, so that time what happens, the jumping of electrons increases beyond the rated capacity of the diode. This is very important. Okay, rated capacity of the diode. Okay, already diode will have certain capacity, but if we increase the reverse voltage, that time the electric field will be increased, high electric field will be created across the junction, so that the current will be increased. Okay, the electron increases beyond the rated capacity of the diode, so that the junction breaks down. Okay, so that the junction breaks down. So this Zener breakdown is termed as temporary breakdown. Okay, temporary breakdown. That means if you remove the reverse voltage, again the junction will regain its original path. That means original function, regain its original function. Okay, this is Zener breakdown. But when we come to the avalanche breakdown, when the avalanche breakdown occurs, when we apply, that means when the reversed biasing is applied across the junction, okay, here what is happening in the sense, the electrons, the kinetic energy of the electron, listen carefully, the kinetic energy of the electron is increased. So the electrons will move very fast, that means we will have the very high velocity. The kinetic energy is increased means its velocity is also increased. So the electrons are moving with very high velocity. So by the time it collides with other atoms, okay, it collides with the other atoms. So that if it is colliding the other atoms means it transfers its energy to the atom. So that time the electrons in the atoms gaining the energy, and then it will come out of the atom. So more and more number of free electrons and more and more number of charge carriers will be created. So more high electric field, high reverse current will be produced. So because of this current, the avalanche breakdown mechanism occurs in diode. Okay, so this is the case. In case of Zener breakdown, high electric field is produced. High electric field is produced. Okay, but here what is happening, when we apply the reverse biasing, so high reverse biasing voltage is applied, the electrons are getting the kinetic, that means the kinetic energy of the electrons are increased. Due to that, the electrons are getting very high velocity. So due to this very high velocity, the electrons are colliding with the other atoms in the material, so that the electrons are detached from the atoms. So the electrons, more and more number of electrons and holes are created, so that it produces very high reverse current. Okay, so because of this, the avalanche breakdown occurs in this diode. But this avalanche breakdown is the permanent breakdown. Okay, so if you that means if you remove this voltage reverse bias or bias also, it will not, that means the junction never come regain its original function. Okay, so it totally damages, okay, it totally damages the PN junction. Thus, as long as the current in the diode is limited, listen carefully, as long as the current in the diode is limited, the Zener diode will not, the Zener diode will not destroy the junction. It will not destroy the junction. But the avalanche breakdown, destroys the junction. Okay, this is the permanent. It destroys the junction, but it does not destroy the junction. This is the difference between them. Okay, so now let us see the comparisons of Zener and avalanche breakdown. Generally, the Zener breakdown occurs at the voltage of, so Zener voltage is represented by Vz, Zener voltage. It occurs near the voltage of 5 to 8 volts. Okay, here it is 5 to 8 volts. But the avalanche breakdown occurs greater than 8 volts. It occurs greater than 8 volts. Okay, so this is the main difference. Here Zener breakdown voltage will be around 5 to 8 volts, but avalanche breakdown means greater than 8 volts. Okay, so the valence electron, in this case of Zener breakdown, the valence electrons are pulled into the conduction band due to the high electric field. The main reason is high electric field. But here, due to the collision of electrons with the other atoms, that is the main reason here. And then if you increase the temperature, okay, if you increase the temperature, it decreases the Zener breakdown voltages. So for Zener, the negative temperature coefficient, okay, negative temperature coefficient, and avalanche breakdown is this increases if you increase the temperature, it increases the breakdown voltage. It increases the breakdown voltage. So it is positive temperature coefficient. If you increase temperature, the breakdown voltage is also increased. That's what it is, positive temperature coefficient. Okay. If you see the VI characteristics of Zener breakdown, it has the sharp curve. Okay, we can see the sharp curve, but it is not as short. Avalanche breakdown curve is not as short. Okay, is not as short. Right, this is the another difference. And already I said it occurs in heavily doped materials and it occurs in lightly doped materials. Okay, so these are the comparisons. Okay, so Zener breakdown voltage occurs due to the high electric field, whereas avalanche breakdown occurs due to the collision of free electrons with the atoms. Okay, so the Zener breakdown is the temporary breakdown. Okay, if you remove the reverse voltage, again it will regain its function. The PN junction will regain its function. But the avalanche breakdown is the permanent breakdown, so it will totally damage the PN junction. Okay, this is what the difference between them. Okay, this is the difference between Zener and avalanche breakdown. Thank you everyone.